Telephone cables are generally not as sensitive to magnetic interference as coaxial cables due to their twisted pair configuration, which helps cancel out external magnetic fields. However, strong interference can still cause crosstalk between the pairs. Coaxial cables are more sensitive because their single center conductor is surrounded by a grounded shield, offering protection. If the shield is improperly grounded or the interference is too strong, signal degradation can occur. A C90 armored cable features a metal sheath for additional magnetic interference protection, but keeping it away from strong magnetic fields is still crucial. Documented cases show magnetic interference causing issues. For example, a telephone cable run parallel to a power line experienced crosstalk, hindering conversation clarity. A coaxial cable near a large motor suffered signal degradation, leading to poor television picture quality. To minimize magnetic interference, keep cables away from strong magnetic field sources like power lines, motors, and transformers. If separation is impossible, use shielding like metal conduit or shielded cables. Magnetic interference poses a threat to telephone and coaxial cables, but proper precautions can effectively minimize its effects. Firstly, understand the sensitivity differences between cable types. Secondly, ensure proper grounding of coaxial cable shields. Thirdly, utilize a C90 armored cable where appropriate. Fourthly, maintain physical separation from magnetic field sources. Fifthly, employ shielding methods when separation isn't feasible. Strong magnetic fields can disrupt electronic equipment and cables. The severity of the interference depends on several factors, including the strength of the magnetic field, the distance between the source and the cable, and the type of cable. The armor of a C90 cable provides a degree of shielding, but it's not a complete solution. Here's a more detailed look at the types of cables and potential issues. Telephone cables, typically using twisted pairs, are designed to minimize electromagnetic interference. The twisting helps cancel out induced noise. However, strong magnetic fields can still induce currents in the wires, leading to audible noise or data corruption. The longer the parallel run with the power cable and the closer the proximity, the greater the potential for interference. Coaxial cables are more susceptible than twisted pair telephone lines. The shield is designed to prevent interference, but its effectiveness relies on proper grounding. If the shield isn't properly grounded at both ends, it can act as an antenna, picking up stray electromagnetic fields. This can result in signal degradation, reduced signal strength, or even complete signal loss. A C90, or armored cable, offers better protection than standard non-metallic sheath cable because of its metallic armor. This armor acts as a shield against electromagnetic interference. However, it is crucial that the armor is properly grounded to be effective. Without proper grounding, the armor can actually worsen the interference by acting as an antenna. Even with the armor, running a C90 parallel to power lines for extended distances is not recommended. The magnetic field can still penetrate the armor, especially if the armor isn't perfectly continuous. There are several ways to mitigate potential problems with magnetic interference. Firstly, physical separation is the most effective method. The further the communication cables are from power cables, the less interference there will be. A general rule of thumb is to maintain at least 12 inches of separation, but more is always better. Secondly, use conduit. Running communication cables in grounded metal conduit provides significant shielding against electromagnetic interference. The conduit should be properly bonded to ground to be effective. Thirdly, use shielded communication cables. Shielded twisted pair cables, for example, have a metallic shield around the wires that helps to block out interference. These are more expensive than unshielded cables, but they can be worth the cost in environments with high levels of electromagnetic noise. Fourthly, ensure proper grounding. All shields and armors must be properly grounded to be effective. This means connecting them to a reliable ground point using a low impedance path. Improper grounding can make the problem worse. Fifthly, avoid parallel runs. If possible, avoid running communication cables parallel to power cables for extended distances. If a parallel run is unavoidable, minimize the length of the run and maximize the separation. Sixthly, consider the equipment. Some equipment is more susceptible to electromagnetic interference than others. If you are experiencing problems with interference, try using equipment that is designed to be more resistant to noise. In some cases, you might need to install filters or other noise suppression devices to reduce the interference. Seventhly, check for ground loops. Ground loops can create significant amounts of electromagnetic noise. The ground loop occurs when there are multiple ground paths between two pieces of equipment. This can cause current to flow through the ground wires, which can generate noise. To prevent ground loops, use a single ground point for all equipment. Eighthly, use fiber optic cables. Fiber optic cables are immune to electromagnetic interference because they transmit data using light instead of electricity. If you are in an environment with very high levels of electromagnetic noise, fiber optic cables may be the best option. Ninthly, diagnose with specialized equipment. If you are experiencing persistent problems with electromagnetic interference, you may need to use specialized equipment to diagnose the source of the interference. A spectrum analyzer can be used to measure the levels of electromagnetic noise in the environment. Tenthly, consult with a qualified electrician or engineer. If you are unsure how to address a problem with electromagnetic interference, it is best to consult with a qualified professional. They can assess the situation and recommend the best course of action. Always consult local electrical codes to ensure that all wiring is installed in accordance with safety standards. The National Electrical Code, or NEC, provides guidelines for separating power and communication cables. Understanding these guidelines can help prevent problems with electromagnetic interference and ensure safety. Magnetic fields are created by the flow of electric current. The strength of the magnetic field is proportional to the amount of current flowing. Power lines, motors, transformers, and other electrical equipment can generate strong magnetic fields. These fields can induce currents in nearby conductors, such as telephone and coaxial cables. This induced current can interfere with the signals being carried by the cables. The severity of the interference depends on the strength of the magnetic field, the distance between the source and the cable, and the orientation of the cable. Cables running parallel to the source of the magnetic field will experience more interference than cables running perpendicular to the source. Shielded cables are designed to reduce the amount of interference. The shield is a conductive layer that surrounds the inner conductors of the cable. The shield is connected to ground, which helps to block out electromagnetic interference. However, the shield is not perfect and some interference can still get through. The effectiveness of the shield depends on the quality of the shield and the frequency of the interference. Higher frequency interference is more difficult to block than low frequency interference. Grounding is essential for preventing electromagnetic interference. A properly grounded shield will provide a low impedance path for the induced current to flow to ground. This reduces the amount of current that flows through the inner conductors of the cable. A proper grounding can actually make the problem worse by creating a ground loop. A ground loop is a situation where there are multiple ground paths between two pieces of equipment. This can cause current to flow through the ground wires, which can generate noise. To prevent ground loops, it is important to use a single ground point for all equipment. When running cables, it is important to follow the NEC guidelines for separation. The NEC specifies minimum separation distances between power and communication cables. These distances are designed to prevent electromagnetic interference and ensure safety. The NEC also specifies requirements for grounding and bonding. These requirements are designed to ensure that all equipment is properly grounded and that there are no ground loops. In addition to following the NEC guidelines, there are several other things that can be done to minimize electromagnetic interference. Firstly, use shielded cables whenever possible. Secondly, avoid running cables parallel to power lines or other sources of electromagnetic interference. Thirdly, keep cables as short as possible. Fourthly, use filters or other noise suppression devices to reduce the amount of noise in the system. Fifthly, consult with a qualified electrician or engineer if you are experiencing problems with electromagnetic interference. AC90 cable's armor provides a significant degree of protection. This armor is typically made of aluminum or steel, providing a continuous conductive path around the conductors inside. This conductive path acts as a Faraday cage, which attenuates electromagnetic fields. The effectiveness of the armor depends on several factors, including its thickness, the material it's made of, and how well it's grounded. A thicker armor made of a highly conductive material like copper will provide better shielding than a thinner armor made of steel. Proper grounding is essential for the armor to function effectively. The armor must be connected to a suitable ground point to provide a path for induced currents to flow. If the armor is not properly grounded, it can actually act as an antenna, picking up electromagnetic interference and radiating it into the conductors inside. In cases where AC90 is run near power lines, additional precautions may be necessary. This could include using additional shielding, such as running the AC90 inside of a metal conduit. It is also important to ensure that the AC90 is properly grounded at both ends. The NEC provides specific guidelines for grounding and bonding electrical systems. These guidelines are designed to ensure that electrical systems are safe and that electromagnetic interference is minimized. When working with electrical systems, it is always important to follow the NEC guidelines and to consult with a qualified electrician or engineer if you have any questions. The sensitivity of equipment varies widely. Older telephone equipment, for example, may be more susceptible to interference than newer digital equipment. Similarly, some types of coaxial cable are better shielded than others. It's also important to consider the type of signal being carried by the cable. Analog signals are generally more susceptible to interference than digital signals. This is because analog signals are continuous and can be easily distorted by noise. Digital signals, on the other hand, are discrete and can tolerate a certain amount of noise without being corrupted. When troubleshooting electromagnetic interference, it's important to consider all of these factors. It may be necessary to experiment with different shielding techniques, grounding methods, and equipment configurations to find a solution that works. Here are a few additional tips for minimizing electromagnetic interference. Firstly, use twisted pair cables for telephone and data communications. Twisted pair cables have the wires twisted together, which helps to cancel out electromagnetic interference. Secondly, use fiber optic cables for critical data communications. Fiber optic cables are immune to electromagnetic interference. Thirdly, keep power cables and communication cables separated. Fourthly, use surge protectors to protect equipment from voltage spikes. Fifthly, install filters on power lines to reduce noise. Sixthly, use shielded enclosures for sensitive equipment. Seventhly, ground all equipment properly. Eighthly, consult with a qualified electrician or engineer if you're experiencing problems with electromagnetic interference. Always follow the manufacturer's instructions for installation and operation of equipment. Improper installation or operation can increase the risk of electromagnetic interference. Consider the frequency of the signals involved. Higher frequency signals are more susceptible to interference than lower frequency signals. Use appropriate shielding and filtering techniques for the frequencies involved. Be aware of the potential for common mode noise. Common mode noise is noise that is present on both the signal and ground conductors. Common mode noise can be difficult to filter out. Use balanced circuits to reduce common mode noise. A balanced circuit is a circuit where the signal is transmitted on two conductors that are equal in impedance with respect to ground. Balanced circuits are less susceptible to common mode noise than unbalanced circuits. Consider the environment where the equipment is being used. Industrial environments typically have higher levels of electromagnetic interference than residential environments. Use equipment that is designed for the environment where it will be used. Be aware of the potential for electrostatic discharge. Electrostatic discharge can damage sensitive electronic components. Take precautions to prevent electrostatic discharge. Use anti-static mats, wrist straps, and clothing. Keep the humidity level in the environment relatively high. The best approach is a layered approach. Start with the easiest and least expensive solutions, such as separating power and communication cables. If that doesn't solve the problem, move on to more complex and expensive solutions, such as using shielded cables or installing filters. Document everything that you do. This will help you track your progress and identify any patterns. Be patient. Troubleshooting electromagnetic interference can be a time-consuming process. Don't get discouraged if you don't find a solution right away. Keep experimenting and you'll eventually find a solution that works. Remember that safety is always the top priority. Never work on electrical equipment unless you are qualified to do so. If you are not sure how to do something, consult with a qualified electrician or engineer. Also, remember that local electrical codes will dictate the types of practices to use and how to use them correctly.